I've decided to make a separate video for each of these. We're going to do B. Aluminum sulfate is aluminum is Al. Sulfate is SO4. We're going to need parentheses here because aluminum is a 3 positive charge. Cation and sulfate is a 2 negative. So 2 negative, 3 positive. I'm going to crisscross. And so we're going to need a parenthesis to indicate we have 3 sulfates. Otherwise that would look weird without the parenthesis. All right, that's all soluble. And then ammonium hydroxide. Ammonium compounds are also soluble. No exceptions. All right, that's a 1 positive, and hydroxide is 1 negative, so those charges are going to cancel out. All right, positive and negative. All right, we don't write charges in our formula, so we'll erase that. And that's also soluble. That's going to produce what? All right, let's switch these cations. Okay, I'll write the sulfates first. The ammonium ones, without exception, are all soluble, so I'll do that one first. Ammonium, and then we're going to need a parenthesis around that because sulfate is a 2 negative charge. So 2 negative and 1 positive. We're going to crisscross, bring that 2 down there. And that's soluble. The one that's not soluble, hydroxides are usually not soluble. So that's going to be AlOH3 because that 3 came from aluminum's 3 positive charge, and then hydroxide has a 1 negative charge. We're not going to write that 1. Now this is, I ran out of space, but there's your precipitate. All right, maybe I can squeeze that in there. Okay, let's balance this. All right, we've got, notice there's 2 ammoniums on the product side, and there's only 1 on the reactant side, so I'll put a 2 there in that coefficient. That's also going to give us 2 hydroxides. Oh man, I forgot to, you know what, let's show our work. There's 3, I forgot this 3 positive. I gotta crisscross it down there. Okay, so let's show our work here. Aluminum, there's 2 on the reactant side. Polyatomic ions oftentimes are not going to change. So in other words, SO4 is going to remain the same on both sides. So there's 3 sulfates on the reactant side, and ammonium there's 1, and then hydroxide there is 1. All right, in that same order, all right, we got 1 aluminum on the product side. We've got 1 sulfate, 2 ammoniums, and 3 hydroxides. All right, so let's balance the aluminums. Just go top to bottom. Multiply that by 2 to balance. Get 2 on both sides. So we need a 2 there. Okay, let's update that hydroxide. We already had 3. Multiply by 2 is going to give us 6. Go to the other side. Get that 6 to balance out. We need to put that 6 where you see hydroxide, which is right there. So numbers only go in the coefficients. So 6 goes there. Let's update that ammonium with a 6. Got 6 ammoniums. All right, let's go back to the right side. Multiply that by 3 to get 6 ammoniums. And now let's update that sulfate as well, times 3. All right, so we are good now. Everything is balanced. The coefficients are going to be 1, 6, 3, and 2. All right, let me copy that over. Try that again. All right, so now we're going to rewrite the soluble components, the ions, separated, dissociated. Come on, pen. All right, so bring that quantity to the front because otherwise it looks like it's just stuck together, the two aluminums, and they're not. They're freely floating around in this water solution. So don't forget the charges either, and put AQ. All right, now there's 3 moles of sulfate for every 2 moles of aluminum. So 3 SO4s, and they have a 2 negative charge, and put AQ to indicate that they are dissociated. All right, we have 6 ammonium ions, 6 moles, AQ. And don't forget to distribute that there to the hydroxides as well. So equal mole ratio for hydroxides. They have a 1 negative charge, AQ. All right. Now, now to the product side. All right, we have 3 moles of ammonium. Oh, sorry. Multiply. All right, it should be equal on both sides. So we have 6 moles of ammonium in solution with 1 mole of no, oh man, a lot of places to make mistakes here. All right, 3, distribute that. So 3 moles of sulfate, and finally our precipitate, we're just going to write the way it is, 2 Al and then OH3 solid. All right, let's cross out the spectators. Those are going to be the sulfates and the ammoniums, and rewrite whatever's left for our final answer. It's going to be 2 moles of aluminum cations in solution is going to react with 6 moles of hydroxide in solution to produce 2 moles of aluminum hydroxide. Charges all balance out. We got 3 positive charges there canceling out the, 6 positive charges there canceling out the 6 negatives, and on the right side there is no charge. So the charges are balanced and the atoms are balanced as well. Come on, stop recording.